In this video, we want to find a, b, and c in the bracket polynomial such that the bracket polynomial is invariant under the Reidemeister move. So let us see here what this means in an example. Here on the top right, we have a knot on the left-hand side where we have one strain that goes over and then one strain that goes underneath. And so now what we want to do is move them to the right and to the left. And so we get this picture on the right-hand side where we have the strains just moving beside each other. And so since these are the same knots, just different representations, we want that the bracket polynomial of the one on the left should be equal to the bracket polynomial of the one on the right. So what we'll do is first we're going to compute the bracket polynomial of the one on the left and then compare it with the one on the right. So as before, we concentrate on our crossing. So the first thing we'll do is we concentrate on this upper crossing here. So what do we get here? We get a times the bracket polynomial. What? Well, we go on the top strain here, and then we turn to the left, and then we continue along the knot, and then here we also turn to the left, and we continue along the knot. So we should get this picture here. So we're going to get here this loop. And then we get B, and here we go on the top strain, and then we turn to the right when we get to the crossing. And continue along the knot like this, so we should get this picture here. The bracket polynomial of and now we continue, and we want to untie the bottom crossing in both of these pictures. So we start with the one with A, so we always get the A in the front, and then we get another A, and then we'll do the going along the top strain again. So we go along the top, and then we turn to the left here, and then we get this picture. So we get the unknot with two twists on the sides. And now, we go on the top strain and we're going to get B, and we turn to the right. So we get this outer loop unknot with the two twists, and we get an inner circle. So this takes care of the first picture, and now we go to the second one with B. So we have A, what do? We go along the top strain, we turn to the left. So we get a left-hand loop and we get a right-hand loop. And so now you can compare that this is the one you have up here, just to kind of, how do we tell this? And then with B, we go along the top strain and we turn to the right, so we get this big unknot with two loops on the left and the right. Okay, so what do we see now? Well, one thing we can do is here in this bracket polynomial, we have this unknot here that we can move out as a C. So that's one thing we want to do. And then we also want to multiply out. So the first term we get here is an A square times the bracket polynomial of this unknot with a twist on each side. Then secondly, we have here A times BC times, okay, what is left here is also the unknot with a twist on each side since we moved out this inner unknot. So we get A, B, C times the bracket polynomial of this same knot. Plus here we have A times B times the bracket polynomial of these two unknowns with a twist on each of the sides. Plus finally b squared also of the knot of this picture here. And now we can see that 3 times we have the same knot here. So the same bracket polynomial. So we can factorize by that. So we get here a squared from here, then b squared from here, and then a, b, c from here. Plus, well, ABC times this knot over here. And let's go back to our beginning. We really wanted that this left-hand side, which is the thing we just computed, is equal to the right-hand side. So we want that this is equal to, well, just the simple bracket polynomial of this knot here, which already appears here. So let me be a little bit more specific and put a 1 in front of here. So now, as usually for polynomials, we can just compare coefficients. Yeah, so if this polynomial has to be equal to this polynomial, then the coefficients have to be the same. So in this case, that means the coefficient in front of these have to be the same. So that means 1 is equal to AB. Well, and secondly, the coefficient in front of this polynomial here has to be equal to the one here. It doesn't appear here, so that means that this guy has to be 0. Okay. Well, let's just concentrate first on this equation. This means that b is equal to a inverse. And so we can replace all the occurrences of b in the second one by a inverse. So we have here a squared we don't touch. B gets replaced by a to the minus 1, so b squared becomes a to the minus 2. A again we don't touch, b gets replaced by a to the minus 1, c also gets not touched, and then this is all equal to 0. And now we want to solve this for c, and so this becomes minus a squared minus a to the minus 2. And so now the two important equations are what? Well, b is equal to a to the minus 1, so I can replace b by a, and also my c in the bracket polynomial can be replaced by an expression in a, which is a little more complicated, but